Welcome back, everyone. Today, we have a scintillating topic to discuss with founding engineer here at Wordware, Tamir. He's been doing a lot of our early work on evaluations. If you've ever built AI systems or AI agents, you know that evaluation is a really important part of actually making sure that the process and the product works. So, really excited to have you here. Also, shameless plug, Tamir has been our resident recruiter in charge of a lot of our engineering hiring and has been hosting a ton of exciting events around the city. So if you're in San Francisco, we would love to have you. We'll have more information in the description below, and also we'll be sharing on all of our platforms going forward. Tamir, you want to just give a quick intro of yourself and how you got here?
Yeah, so I'm originally from South Africa, born and raised in Johannesburg, studied computer science or electrical and computer engineering at the University of Cape Town. I fell in love with startups during university and was very close to dropping out. I built a textbook marketplace, make it more affordable for students to buy and sell textbooks. And I just got hooked building stuff and did a whole bunch of things for the next few years. Started a startup in Singapore, went through IC, but ultimately wanted to be in the heart of where AI is being built. And that's here in San Francisco. It's here at
Yep.
Wordware. And that's how I'm here today.
Awesome, man. And it's been so much fun working with you these last few months. And it's been so exciting to see how far the product is going. Your latest spike, so to speak, has been on evaluations. And so as we get further into building agents and making AI useful in your everyday life and working on human and AI collaboration, this is a really, really important area that we need to nail. And of course, we want our best and brightest on this problem. So I guess just to start off, I mean, for those who aren't in the know about what all of this is about, like, what is an evaluation? What does evaluation actually mean when we're talking about AI agents? How is it different from testing traditional software?
Yeah, testing is, and in the world of like traditional software, you have what's called like a deterministic outcome, which means if I put, like, let's say I have a calculator, and this calculator it adds two numbers. It says 2 plus 2. And that's what, like, inside of it, it's going to add these two numbers, and then it's going to give me the answer. In traditional software, I can always have confidence that for the same input, I'm going to get the same output. At least I should. That's part of like the conditions of like traditional testing. And it's very useful because then you can make sure that your code is working. And when you ship it to production and you make changes, you can be sure that it's going to still work. And that's why Wordware works all the time and never goes down. But the converse of this is the world of LLMs, where there's non-deterministic outcomes. So you can ask an LLM something 100 times and you can get 100 different answers. And this is really important then in cases where like the answer of that LLM is something very important. So like, let's imagine a healthcare provider or a hospital that's building an LLM and they need to keep to like HIPAA standards, or maybe an education system needs to keep to COPPA standards.
Mm-hmm.
So there's like particular rules that system has to follow. Like you can't mention the patient's name if you're like answering, like imagine, so one of our customers had a thing of auto replying to reviews on Google Reviews. So
Yeah.
a patient would leave a review on their website, and they would have a thing be like, "Oh, thank you so much, great, it was great having you." Built like an AI system to do this. They can't necessarily mention the patient's name, the diagnosis. It has to remain very generic. So you need to have some sort of way of being like, when I ask the AI to do this thing, when it came out with an answer, did it meet a set of criteria? Did it meet a set of things? And then that criteria can be different things. It can be, how fast was it? Like, was it speedy?
Mm-hmm.
If we're dealing with like very like urgent systems, like maybe it's like a 911 responder and you need to send it to the right 911 operator quickly, you need that thing to be fast. Maybe you care about particularly like keeping to certain standards or rules, like in this HIPAA thing, like it can't mention the patient's name. So what you do is you set up another LLM almost, and it's called an LLM as judge. And that LLM will then look at the output that was produced by the system, be like, here's my patient, write me a review. Okay, this is the actual review. And it has a set of rules that it will then evaluate that output against.
Okay.
And that's the idea then of evaluations. It's like how do you test and how do you put metrics and like performance to the things that come out of AI?
Yeah, and so just to summarize so that I understand well, right? Like traditional software, you put in certain inputs, the outputs are deterministic. So you know that 1 + 1 = 2. Versus when you're building AI systems, the outputs are not always the same. They can be different. The question is, how do you narrow the level to which the AI is being too creative and making sure that it is kind of reined into a certain set of outcomes that you want to achieve?
Yeah, I think that's spot on. I think it's not necessarily not being too creative. You can still have your LLM do flippin' cool things and be super creative and witty and crazy. You can even use that as a means of maximizing that. You want to be able to like use evaluation. So like in our particular case, we might have like an AI system that will summarize your emails and then send you a Slack message with in like a voice note thing, right? You want this voice note to be good, right? That's summarizing your emails. The way in which you can then think about making it better is you could write a set of evaluations on that voice note, like on the output that comes out, across certain like quality criteria. So like how short is it? How funny is it? How relevant is it? So there's a way in which becoming more specific and scientific about your output, but then trying to like say like, cool, like if we get this thing to be like super short, super witty, super relevant to my particular context, it could be perceived as more creative. So there's like an emergent effect that happens when you can actually evaluate your outputs on a very granular level. And that is one of the challenges of evaluations, is that the quality of your evaluation is as good as the quality of the evaluation prompt that you're using. And the more specific you can be with your evaluation prompt to a particular aspect, the better that evaluation is going to be.
And I definitely slightly misspoke there, which is like, at the end of the day, the outputs of what you want the requirement there could be for it to be really creative. Or how funny is it?
Yeah.
In some ways, you could even have part of the evaluation be like, is it creative enough? So yeah, creative is the wrong word there. It's more, is it giving you what you want?
Yeah, exactly.
Awesome. So talk a little bit about the real world impact here. Like, what are the biggest risks of getting evals wrong? Like, any horror stories you've experienced or heard of that you're trying to optimize against? Like, what is the worst case scenario if you don't get this right?
So it is like a massive part of the way in which the traditional LLMs, the big ones, ChatGPT, Anthropic, Gemini, they're built, is using these like initially it was this human feedback where people were given different responses and they would rank which response they necessarily prefer and give feedback. There you have a human evaluator. The human is evaluating this thing.
Is that like reinforcement?
Okay. That's part of the reinforcement system. And what's interesting is that there's been a few cases where the AI system can kind of identify what it is being tested against. So you have to keep the eval, if you're training a foundational model, you have to keep the thing that's evaluating it and the actual like brains separate, because if it learns being like, oh, I know I'm going to get asked it's kind of like a kid that knows the questions that are going to get asked in the test.
Yeah.
Right? In that way, they're never going to actually learn or understand the content. They're going to memorize the answers. And so there have been many cases where like the AI is going to overfit to the evaluation because that's the thing it's trained on.
Yeah.
And like the reward function would be like, good job, you passed the test. Like, how am I going to pass the test? So there's some interesting like meta things that you could say that like I did a whole thing. My passion is still in like education. Previously, I did an edtech, two edtech startups, and a huge thing is just around how do you teach people, how do you get people to learn from a position of real first principles understanding. It's very interesting to see how we have such a default thing of these test-based system, and how both in our school system, we end up getting a kind of incentive structure to memorize, to do well in the test. And that same thing is happening in AI development, for a lack of a better way of knowing how to actually test understanding. And maybe that's a huge thing of like, how can we actually test understanding in a more native way of true understanding, as opposed to getting a good answer on a test.
Yeah, I mean, even if you think about like math, right? Like, can you derive the equation versus are you just memorizing the formulas?
Yeah.
It's really kind of what you sort of want the LLM or for AI to be able to reason and figure things out rather than just like memorize and regurgitate. Although, from what I understand, like the early days or even till now, a lot of it is sort of it's fed information and it's coming back with maybe not memorized stuff, but it's like it's learned on all
Yeah,
of
it's
this
pattern
corpus of
recognition.
information.
Like it's developed. We still have no idea how like AIs are working under the
Yeah.
hood. It's like an emergent system with millions and millions and millions and millions of different layers of neurons that's like behind the scenes, and we get to see like, oh, cool, it made an amazing image. And like even like the researchers behind the stuff is like, I don't know how it did that.
Yeah, I mean, it all goes back to the fact that AI is non-deterministic versus like traditionally software is deterministic.
Yeah.
And so when you're dealing with outputs that are coming from a machine and using that versus inputs that are going in from a human, and it's just like the whole world of AI, the whole world of deep learning in general is not fully understood. Like we've gotten it to work, but we don't exactly know how it works. Awesome. And I guess how do you balance sort of testing for you were mentioning this a little bit earlier, right? How do you balance testing for things like accuracy? Because you can get really, really good accuracy if you give a model long enough, or it's a reasoning model that takes a lot of time to think and do its thing, versus, testing for speed or experience or cost. Is there a difference in your approach when you're writing evaluations or when you're building evaluations?
It all depends on the system and like the requirements of that system. And definitely a mistake that engineers tend to make is caring a lot about the things that are easily measurable. Certainly, a mistake I've fallen into in the past is optimizing for performance too soon, because like that is a very easy thing we can see, and like it's almost like as purists being like, I'm a flipping good engineer, this thing is going to be like this prompt is going to be super efficient, it's going to be super affordable, it's going to be super fast. But if your system is one that can take minutes to run, and from an end user's perspective it doesn't matter if it takes 1 minute or 3 minutes or 10 minutes, spending a lot of time trying to evaluate on performance is a waste of time. You're better off focusing on other metrics that is ultimately going to make the difference to your users. So it's really understanding the system that you're trying to build and what's important to your users, and then making that the first thing and just caring about that. Once you have a system that's working for that and you're able to optimize for that particular metric, cool, you can start adding other things. But premature optimization is the bane of every engineer, and perfect is always the enemy of good in that context. To bring it into like real world examples, I think the one I mentioned previously, like if you have some sort of AI system that needs to route between 911 operators, their speed is super important.
Yeah.
So you care a lot about the performance of the AI in routing quickly as well as accurately. Obviously you want that accuracy, but for example at Wordware, where we're doing kind of like these background workflows, these things that are like every day summarize my email, or every day after I get a new applicant to my job, send me an email and send my boss an email being like, this guy's flipping awesome. If that happens in 10 minutes or 5 minutes, doesn't really matter. What matters in that case is how good was the summary that I got about the new applicant that just applied, and that's the focus then of the eval thing.
So as you've been sort of working on eval, like you've been kind of primarily responsible for that area here. Has there been anything that's kind of stood out to you as like aha moments or things that you think are maybe you didn't think of before that you've had to think of now?
The hardest part right now, and it's interesting, like the term eval has kind of evolved. Like in the purely traditional sense, eval is purely on like evaluating a non-deterministic output, like a piece of text, being like, how good is this essay? How good is the summary? How good is this voice note across whatever kind of criteria? Evals have morphed into this much bigger thing, which I'm talking about, like in regards to evaluating your performance, your cost, all of these other kind of metrics. But then equally, it's just evolved into this whole thing of testing AI systems, where like testing an AI system is evaluating it. And one of the most interesting parts for me is how flipping hard it is to evaluate real world agents. The reason for this is let's say you have some sort of system. Like in our case, we have a generic thing that like every time I get an urgent email, send me a Slack message and tag the appropriate person in my Slack channel that also needs to like hear about it. Let's imagine like that's a workflow. If you build this AI agent, how do you determine if that thing actually happened in the real world? And especially if you're going to have a generic kind of thing. The beauty of AI is that it's going to interface with all of our tools. It should work with Slack. It should work with Attio. It should work with HubSpot. It should work with Google Docs. It should work with Google Sheets. And if you want these AI systems to be able to like, pull this data from Google Sheets and add it to Attio and do a dance and then add a joke there, you want to figure out, did the thing actually do it? And in order to actually do that, kind of involves simulating the whole world.
Yes.
Because like if you want to test that with end users, like say a user comes to us and is like, I don't know, let's say theoretically they were like, if I get the Slack message, quickly transfer $1,000 to my other bank account, because like, yeah, this is actually a great example. Let's imagine like we had an AI system that was like monitoring crypto, and if it started to notice the crypto drop, be like, quickly log into my Coinbase thing and like sell. You want to test that works. How do you test that works? You don't want to actually do that to the user, right? The user's going to be like, no, don't transfer $1,000. So you need some sort of way of evaluating if the thing that the agent has set out to do, in this case, this like crypto protector, without that thing actually doing it. And that is a massive problem. That's like a huge thing of, will the agent reliably execute the thing that it needs to execute across the thousands of different potential services, Google Sheets, Slack, Coinbase, and whoever figures out that problem, it will be a very wealthy person.
Yeah, I mean, I remember when I was at Stripe, it's known to be a very developer-friendly API for integrating payments. And one of the features, a small feature, but a really important one, was the ability to just have like a fake credit card number that could be used to simulate payments. So traditional software world, you would have that. But now what you're kind of saying is like, imagine you needed that for like every application you use and every bank account and every, potential thing that an agent could do for you. Maybe there's a world in the future where like, today we talk about developer friendliness. In the future, it'll be like AI developer or
100%.
AI eval
100%.
friendliness.
100. Like most of the content of the entire internet and the way we've thought about software up until this day has been to optimize for the person, for the engineer or the end user. But one of the biggest shift that's going to happen with the AI revolution is that the internet is going to be built for AI. One simple example is websites starting to add, so like if you've done SEO or anything like this, like about meta tags and like the correct title for a website and the meta description and an image and how you do like good SEO ranking. The way that's evolving is to something called LLMs.txt,
right,
which is a markdown or a representation of that website in an LLM-friendly format. And keeping that up to date and keeping that readable for AIs will be super important. And then this whole thing of the sandbox-like environment where like we're going to want to have AIs be able to operate in a sandbox, like to be able to use a virtual credit card, like in the case of Stripe, but then for all these different things. So I could imagine that analogy of how Stripe made a fake credit card, that analogy then extending to like entire fake websites, entire fake APIs that AI would just be using. And then it would be a switch mode to be like development to production, the same way it's done in Stripe.
Yeah. And similarly, cool. Like, I guess the same thread or the same thought is that like in the traditional software world, you have APIs so that your your product can interface with other products. But what's in between them is code that connects products together using APIs. Whereas in the future, there will be agents trying to access products, and that's where sort of MCP comes into play, where
Yeah.
it's like you have the ability for models to tap into the different functionalities that a product has, rather than you're building a deterministic software product that's like calling a specific endpoint.
Yeah, I think we're so early in that whole thing. Even MCP, it doesn't begin to solve all of the problems. Google has like a framework of an agent to agent architecture, and just like the thinking and the kind of infrastructure that needs to be done around agent to agent communication, even like within, like even when you're just building your own product, it's the Wild West out there. Then when you try and interface with other products, other agents that you don't know how they're in, it's like, I don't know, the Wild West in space, blindfolded with no oxygen. That's a weird analogy, but you get the gist.
Do you feel there, like a lot of people make the analogy of the time that we're living in right now being sort of similar to the early days of the internet? Do you think that that's true? Is there a better analogy?
I think it's very true. I think it's bigger because it's like the internet gave us a means of connecting with one another. This is like a artificial intelligence. It's an augmented way of thinking and democratizing access to thinking massively, and just like the implications of that. Ultimately, yes, I think it's a comparable analogy, being like we're looking at a different world that needs to evolve and take place in the same way that the world adapted to websites becoming a thing, and then when Apple came out with the App Store and then apps being a thing, the ecosystem and the way in which technology works and evolves is completely in flux right now, and it's a very exciting and equally scary time to be a part of it.
Yeah, because I remember, like, if you think about like how early we are in this process, in this super cycle, as people are calling it, like there's basically the analogy to me is like in the early days of the internet, there were all these like really trash websites that were just like, if you looked at them today, you'd be like, what were people even thinking back then? What were they even using to build this? GeoCities and, whatever, like all these websites that people were building. And now you can like spin up a website by prompting. And it looks like beautiful and it's like amazing. Like what's that evolution? Peek into the future a little bit, and what do you feel like the evolution of, because like right now I think like in many ways, if you look at Wordware, it's like an early product for building agents, but it's still so hard. Like a lot of, like, we see this day in and day out with our customers where we make it a lot easier to work with these systems, but it's still really hard to get the output that you want and to get the products to do exactly what you think it should be doing. So like, if you peek into the future a little bit, like how do you think that will evolve maybe over the next few years?
I think one big thing is natural language as the primary means, like just speaking, becoming the primary means in which we do our work. Most knowledge work, like if you're looking at Google Sheets, if you're looking at coding, so like Google Sheets for like financial analysts or data scientists, whatever it might be, coding for engineers, Google Docs for lawyers, that perhaps is a little bit more natural language-ish in a sense. But there's like a way in which the software is like creating this mapping of the way in which we interact with it. Like you have to work inside the columns of a Google Sheet, and then you have to use the right formulas to click and drag and do the kind of formulas and things you want. Similar in coding software. All of these are layers of abstraction around a computer and around like the software that it uses in order to do real stuff in the world. So it's all very abstract. The point being is that what LLMs can start doing is just translating natural language and speaking into the actions you then want to take into the real world. So you want to create a report that summarizes and visualizes the jobs of farmers in northern Uganda from 1920 to 2020. Already today, you can just type a prompt in order to do that. But here in San Francisco, we see that a lot. The rest of the world hasn't caught up. And even in San Francisco, like we're still not seeing the full extent of it. So the core interface that we've always been using of like a mouse clicking and dragging and like specialized software to represent data structures or like particular ways of doing things, that's just going to completely change. And it's going to be a natural language first thing of you just going to be speaking to your computer the same way you and I are speaking, and the same way like human beings. The computer is something that has been around for like less than 100 years. Yeah, less than 100. Yes, definitely less than 100 years, right? For most of our evolution, the way we get things done is by communication using our voice and using language. That is what AI is allowing the revolution of computers to start doing, such that we can start speaking to software the same way we speak to one another. And then everything around that will change. So I think voice is going to be a huge thing. I think intuitive platforms that let you build stuff and do cool stuff just using natural language will be the big things. And then it's just like all going to be like much more natural. I think it's going to look a lot less like you're on your phone or on a computer. It's going to look more like how we've evolved over millions of years in regards to communication and solving problems.
Yeah, in some way, I think at least for me, a few years back, if you asked me about AI, and at that time it was very nascent and early, let's call it 8 to 10 years ago, the thought that came to mind when you said artificial intelligence or AI was like a robot, like a physical robot, like walking around like a humanoid robot, versus what is really happening in the initial foray of AI into like really powerful AI that's like replacing human work and stuff like that. It's not that at all. It's basically language based. It's not necessarily like a robot using a hammer. And so I think in some ways it's like the way that we imagine things today and how it should look. That's why it's so hard. It's like you really don't know what you don't know about where it's going to go and where it's going to take us. And that's what's fascinating and thrilling, and part of the thrill is kind of the unknown, right? And so it's pretty exciting to hear about.
Have you seen that? There's that famous like cartoon of this artist predicting what education systems would look like in the year like 2000, and the picture is like these kids in school and they've got helmets on, and like they're transferring the knowledge like through the helmets to them, right? So it's like we only have, and a similar analogy is one of the way in which we thought, like during the Industrial Revolution, you saw a lot more representations of the human as like a system of steam and like pipes and gears. And the point being is that we use our existing understanding of the world, our own like the mental models we have today, and we build those into what the future will be. So like when the Industrial Revolution arrived and steam was the primary thing that was driving it,
Yeah.
everything was steam-based, and the analogies people would think about would be steam-based. Today, it's a little bit more computer-based, and the analogies I think about, being an engineer and a lot of people working in tech, is like computer-based and computation. But like, that is only because we're just limited by our own knowledge of our own mental models. As those mental models change and we figure out like, no, it's flipping, I don't know, chakras. Okay, well, we might need to filter this part out of the podcast. But like something that isn't part of our mental model. And oftentimes that is what ends up being the case, that like the future and science and human progression has this trend of being very counterintuitive, of not ever expecting that to be the way that we thought it was.
Yeah, and it's almost like the things that you think will always be around in the same manner are the ones that get disrupted in some way. If you had asked me, you'd be like, oh yeah, there's going to be like manual labor or other things that'll get replaced, and things that are easier will get replaced. Whereas what seems to be at least getting really, really augmented is like programming has been one of the first areas to be really augmented by AI. And I think that's a little counterintuitive of how that evolved in terms of now it looks obvious in retrospect, because it's like the language models, of course they can produce code, right? But like,
can I bring it full circle to where we started it? The interesting part about why software engineering is the path that it seems to be like, if you look at AI usage, I can't remember the exact statistics, but the vast majority of users, the vast majority of tokens that are generated for LLMs are used for coding, like by like a lot.
By a lot, yeah.
We'll find numbers and put it up. And one of the reasons is that it's really good at it. It's really good at coding. Why is it good at coding? Because it is a easily evaluatable system. That is like one of the feedback loops for coding, because it can write evaluations of being like, when I wrote this code, did it do the thing that I expected it to do? Because it's all inside the computer. It's like the LLM can write the code, run the code, test, did I get the correct output? I did. Cool, the code is good. Or I didn't. I need to keep iterating. That feedback loop can be parallelized across millions of computers and just go boom, boom. But the rest of the world, other forms of technology, electrical engineering, mechanical engineering, aerodynamics, law, healthcare, all of these, especially biology. Well, hopefully we'll get to like computational biology soon. The feedback loops and the ability to evaluate it is so much harder that it isn't as good. So counterintuitively, it's going to be like engineers are building AI that is replacing or augmenting most of the jobs, but it's going to primarily augment the engineers that are building that AI. So it is a funny thing.
Yeah, and to put it in terms of what we're building here, it's like is sort of the mental model you need to sort of get used to is like, at least at Wordware right now, what we're doing is mostly like integrating with other tools. So like with a software system, because everything is in one place and you can deterministically see if it did the thing, it's very different from saying, your evaluation needs to determine, did the transfer between bank accounts occur, or did the message get sent from one place to another? Like that's a lot harder for an AI system to know. And in order to solve that, like you were talking about this a little bit in a conversation we had last week, and I'd love for you to kind of restate it or talk about it in some way, which is like, if you had every resource on earth and all the time in the world, you would do a certain thing for evaluation versus like what's realistic and pragmatic to do.
Yeah. Like, to rephrase that and like bring it to the analogy I was talking about previously, like for a computer writing code, like an LLM, and you wanted to get super good at writing code, it can try and solve a problem, write code, test did the code work, and that's the evaluation. That's the core thing. Like you need to be able to like see, did the thing do the thing that I expected it to do? When it's all inside the same machine, it's the same software that's writing it and looking at it. Cool, very easy. But between those connections, it's like, did this money get transferred from bank account A to bank account B? And those are two different systems and two different APIs. And you want to do that across the entire internet. If you had infinite resources and infinite money, you would create a simulated world. So I would go and make a mock Bank of America. I'd go make a mock Stripe. I'd go make a mock Facebook. I'd mock all of their APIs and then let the AI work in the simulated world. And
a digital twin.
Yeah,
right?
digital, like this, which maybe that's what we are. Who knows? We could just be an eval that some engineer wrote in order to be like, did my agent send the money before I lost all my crypto? God, that would be a bleak existence.
That's like the Matrix, basically.
Yeah, the Matrix, but like such a sad version of the Matrix, It's like, if it's going to be the Matrix, at least let it be something like, I wanted to create happiness and meaning, and I wanted to discover, not be like, I wanted to make sure I didn't lose like $1,000 on crypto. But who knows? Coming back to topic. So yeah, you'd simulate it all, and then it would all be within the same system. The AI has complete control, but you don't have that. So the solution that we're experimenting with is a self-reporting system. So the AI agent would go out and do a bunch of things in the world. And the way that AI agents work is that they create a trace, kind of like a log. You can think of it as like the AI's diary. It's like, I thought I should do this. I went and did this. This is what I saw happen. So this is like a classic thing called the react loop. Yeah. And as it's then, so it's going to be like, let's take the example. When I get an urgent email, send me a Slack message. The AI is going to get this email and it's going to look at it and be like, oh, is this urgent? It's like, yes, I can see it's saying like the production servers are down and like our customers can't use the thing. This is an urgent email. I should send a Slack message. You can literally have the AI write that out. And then it can be like, this is the message I'm going to send to Slack. And you can see the send Slack message thing in its diary. And then what you can do at the end of this long trace is you can have the AI look at itself and almost do like a meta journaling session of its own diary and be like, what did I do today? What did I end up achieving? And it can report like, oh, I sent a Slack message for this thing. What Slack message did I send? I sent the servers were down. guys, get your shit together. Please look at Cloudflare. And you can then run the evaluation.
This is
off
very
of-
topical, by the way. This literally happened yesterday, right? Like
Okay,
the
like
entire
Cloudflare
internet
down.
was down.
And then have the thing report, did it do that thing that you're looking for? So that's great in theory. It will add a little bit of cost because you have to have another LLM call at the end of it to like meta journal and be like, what did I do today?
Yeah.
The issues with it is that it is prone to hallucination because you're not actually checking the outside world. You're relying on the agent self-reporting what it does.
Yeah.
And there's kind of two core assumptions that have to be true in order for this to work as an evaluation thing. One is that the trace information has to be rich enough to reconstruct what happens in the outside world. So if the trace information doesn't include the exact call that was sent to Slack or the exact response that was sent to the service, it's going to be difficult to know exactly what happened. And two, you have to trust that it's accurate. So if you then have, so like I had this the other day where my agent was calling another agent and that agent hallucinated. That agent said it did
That
some
dude,
stuff.
you know.
Yeah, he's the problem. And it told my agents like, oh, I did this thing. My agent was like, oh, okay, cool, I did the thing. And then you go, look, it didn't do the thing. And that's because it hallucinated. So it needs to be rich enough, but it has to be accurate. And then it kind of needs you to have a lot of observability over every part of that in order to make sure that every part is accurately reporting what happens. Yeah, so that's the reporting based end-to-end outcome evaluation.
Is it like, do you think, and this is just me riffing and thinking out loud, but like, wouldn't it be better if like the evaluation agent was like powered by sort of a not as smart LLM? Because like then it wouldn't hallucinate. It would just tell you maybe like yes or no, or could it be like a simpler model or something like that? Would that
So
make
that
it
is a big thing. Most high-scale evals end up working because especially evaluations are the best when you get as specific and as small as possible. And so when you get as specific and small as possible, you don't need these incredibly powerful agents
Right.
and models. If anything, it's a whole thing. Like, don't use the same model that generated your output to evaluate it.
Yeah.
Use a different model. But in general, you can definitely use smaller models for like actually running the like thing. But in regards to generating this report, that is actually like a meaningfully complex task because like you need to look through a big corpus of information, the whole trace, which for some agents might be really long, and accurately then extract this is what it did and how I know it did that thing. Yeah.
Interesting. As you've gone through this a little bit, any tips, tricks, tools you've used, things that you think are exciting that you'd share with other engineers out there, you know?
And let me try split it into like engineers to people because it is. So one thing like writing evals does make you think very deeply about the system that you're building. And I think even it's made me a better prompter for everyday cases because I'm thinking very much being like, how do I know that the output of this is going to be good? And in a way that eval can become the prompt in the first place, right? So it's like, if you are wanting to have a message sent to your boss, right? Let's say you're composer, you're speaking ChatGPT, write my boss an email saying why I should get a raise.
Yeah.
And you want to know, is this a good message or not? You need, if you think about that from the perspective of, I need to evaluate this message, and you then think about what is the qualities of that message that's going to be really good. It should probably be like short and to the point. It should probably like mention these very specific things. So if you almost think about the end in mind for general prompting and like, how would you determine if this thing is good? You become a better prompter. So there is value for, I think, everyday prompters and people working and knowledge workers to think about evals to some extent. For engineers, shout out to Brain Trust. I'm just a big fan of their like system and like just the way in which they've created like their layers of abstraction. And it was just a very nice experience of thinking about running an agent and then having a bunch of like scores that ran against it. So Brain Trust is cool. Get your stuff into the real world. That's maybe one thing I'm even feeling. It's like writing evaluations can feel a lot like doing academic research and being quite removed. And like you can think about things in theory a lot, but until you actually use real world data with real world things, then all of a sudden your evils like break apart because it's like
Yeah.
you thought about it within this like confined thing. So as quickly as possible, go from a evil idea and set into real world data and real world observation, which is the same principle I think for all startups and things in general. Just the quicker you get things out to the real world where shit happens that you could never expect, the better your system's going to be.
Perfect. This has been a short session on evals, and we went to other places too. We talked a little bit about AI in the
Philosophy.
world and philosophical topics, and we'll continue to do that here. Really excited to bring this content to you guys and make sure that you're aware of what we're building here, as well as kind of. I think there's thousands of companies out there right now, like striving to build in AI and build agents, and we just want to play our part in giving back in that to that knowledge base. So yeah, thanks so much, Tamir, for joining us. Again, shameless plug, like drop us a note. We will have other like recruiting events and other things going on that Tamir's taking the charge on. So
Yeah,
we'll love to.
if you're a talented engineer and you've built full stack apps in the past, you're passionate about AI systems, agentic frameworks, we're hiring. Come speak to us.